Today, I'd like to talk about an issue which is very close to my heart. And that's because it's related to the field that I have always loved, mathematics. Mathematics was always for me more than just something I'm fond of. It was my main hobby, my lifelong passion. For me, mathematics is something beautiful, almost like a form of art. But in the case of most people that I've met, mathematics is something to be hated. Something that, to learn, requires a lot of memorization and even more frustration. I have tutored a lot of people in mathematics in the past few years, and I came to understand why they view mathematics that way. It's not because they're bad at math, it's because of the way that mathematics is taught. The average approach at school goes like this. Memorize some formulas and solve a lot of example problems. Now, this couldn't be further away from how I believe mathematics should be studied. Therefore, today I'll present the method that I always use whenever I want to learn any mathematical concept. It's a 4-step method, and I believe that anyone can use it. And to make matters more real, not only am I going to present these steps, I am going to explain a real mathematical concept using them. The concept I'm going to be talking about today is called the boundary of a set. Step 1 is getting a basic intuition. Before you actually dive into any formal notions, you should first get a picture in your mind of what you're even talking about. So, intuitively speaking, what is a boundary of a set? Take a look at this shape. Now, where would you say that this shape ends? Where does it stop being the shape and start being not the shape? Well, most people would say that that's what we intuitively refer to as the outline of the shape. Now, if we treat this shape as a set of points on a plane, then this intuitive notion of an outline translates into our intuitive notion of the boundary of a set. Okay, so now we have a basic intuitive picture in our minds. The boundary is the edge, the in-between, where the set stops being the set and starts being not the set. Step 2 is understanding the formal definition. Now, this is the step that many people wrongly jump into first without having any sort of picture in their mind. But now that we have one, it's going to be way easier. So, what is the formal definition of a boundary? We say that the boundary of a set S is the set of all points P such that every open ball around P contains at least one pair of elements AB such that A belongs to S and B does not belong to S. Scary, I know, intimidating even. And that's because formal definitions have a lot of words. And thus we can sometimes be confused upon seeing them. But in reality, if we have some sort of intuition and we try to see step by step what each and every word means, they often convey a very simple idea. For example, for our purposes, we can basically take an open ball to be a circle. And that means that all that this definition is saying is a point belongs to the boundary if any circle we draw around it, no matter how small or how large, it will contain at least one point which is inside and at least one point that is on the outside. This can be visualized as the following. If we take a point from what we can intuitively consider the boundary, we can see that even if we make a very small circle, it will still contain a point in the interior and a point in the exterior. So now we understand the formal definition. But this is not enough. The next step, arguably the most important one, is to step 3, which is to connect the intuition with the formal notion. Now, this is the step that most people skip. But whenever you actually see that your intuition and the formal definition are in a vague sense equivalent, solving problems becomes way easier. So let's connect the two. Take a look at the previous shape. If we take any point which is clearly in the interior, we can see that we can always find a circle in which we only have interior points. So this is clearly not the boundary according to the definition. If we take a point that we intuitively obviously consider to be part of the exterior, then we also see that we can find a circle which only contains points from the exterior. But when we take a point right on the edge, on our intuitive boundary, this is where we can't find such a circle. And it always contains some part of the interior and some part of the exterior. So we see that whenever we take a point from our intuitive outline, that's when it meets the formal definition of what a boundary actually is. And thus we've linked the two. And now it's time for problem solving. But wait a minute, wasn't this supposed to be about how to learn mathematics without solving example problems? Well, not really. It was about how to learn mathematics without solving millions of example problems. But don't worry, all that we've learned will not go to waste. And that's because once we have an intuition and we've connected it with the formal notion, now not only will we have to solve way less problems to actually be able to do them efficiently, and I mean a lot less, but also they will be far more enjoyable. So let's take a look at the problem statement. What is the boundary of the real open interval from 0 to 1? Well, we can visualize the interval as the following. Now, we can use our intuition about the concept to make a hypothesis about what the boundary could be. So, where would you say that the set ends? Where does it stop being the set and start being not the set? Well, most people would say that it ends at point 0 and 1. So we can hypothesize, using our intuition, that this is in fact the solution. And now, we only have to verify that in a formal way. Whenever we take a point from the exterior on the interval from -∞ to 0, we can always just take a midpoint, and we have found a radius at which we only have points from the exterior. So clearly, those points do not belong to the boundary. An analogous argument works for the interval from 1 to infinity. However, when we take a point from the interior, we can take a midpoint to whichever point is closer, and we can find a radius at which we only have points from the interior. But when we take the points we have hypothesized to be the boundary, those are the points at which we see that even if we try a very small radius, it contains some part of the interior and some part of the exterior. So, we've used our intuition to make a hypothesis, and we know why the formal definition is linked to that because of step 3. And also, we've used the knowledge about the formal notion in order to verify our intuitive hypothesis. And thus, we've solved the problem efficiently. And that's it. That's how you can learn any problem in mathematics without solving millions of problems. Now, a lot of concepts in mathematics are interconnected, but all of the prerequisites can be learned in a similar fashion. And mind you, this method is universal. I have presented what the boundary of a set is. But let's say you are learning the quadratic function. At first, you could get some sort of intuitive notion, for example, a visual intuition, on how a parabola generally behaves. Then you would learn what formally a quadratic function is. Then you would learn why you would imagine the graph of that to be a parabola. And then when you solve problems, not only will they be way simpler, and you'll have to solve way less, but they will also be far more enjoyable. Now, go ahead and use this knowledge somewhere in your life, and go learn some mathematics. Maybe you're not a student anymore, maybe you don't have to do anything mathematical, but you don't have to learn mathematics for any pragmatic reason. You can simply do it to appreciate the art and craft that goes into doing mathematics. Thank you.